All right. Good morning, everyone. Okay. Students, we'll now continue with the concept, and then which is projectile on an inclined plane. Correct? So, I've got an inclined plane of inclination theta naught. Particle is projected at an angle of alpha naught with the incline. Correct? So, particle's trajectory is something like this. Required to find again the same thing: maximum height reached, range, and time of flight. Right? These three things you got to find out. So now, look at the student. When it was on a horizontal oblique projectile, horizontal level, my horizontal velocity remained constant, which is v naught cos theta. And vertical velocity was under gravity. It reduced, came zero, and then came back. Alright. So here what is happening? Here the acceleration was zero along x-axis. But here, if I align my x-axis around the plane, and y-axis perpendicular to the plane, and if I take the component of g, and have a component around the plane and perpendicular to the plane. Around the plane it will be g sine theta naught, and perpendicular to the plane it will be g cos theta naught, because this is theta naught. That means the horizontal motion is also an accelerated motion. Previously, horizontal motion was a constant speed motion, constant velocity. We were going with constant velocity of v naught cos theta, horizontal component was remaining constant. But over here, horizontal motion is also an accelerated motion, where the particle retards as it goes up the incline. Right? So perpendicular, instead of g, we got g cos theta. So around the perpendicular y direction, my particle goes up, stops, and comes back. And on this direction, particle goes on retarding. It can stop and come back. It cannot stop, so it may just continue to move.
Sir, voice is not audible.
Is it okay now?
Yes, sir.
Let me just check. Yeah, it will be audible now. Is it okay now?
Yes, sir, it is.
All right. All right. So along the plane, there is acceleration of g sine theta naught downwards. Perpendicular to the plane, there is an acceleration of g cos theta in the negative y direction. So it's retardation in both the cases. So particle retards, stops, and then accelerates. Here also particle goes on retarding. What happens eventually, we'll talk about it later. But we have got a scenario where now previously my x motion along x-axis, it was symmetric about the line of symmetry. But my parabola's line of symmetry is like this. And this is not like this. My line of symmetry is not like this. So particle goes up, understand one thing clearly. Particle goes up, stops, and comes back. Time to go up and stop is same as time to come back to the same point. Time of ascent is equal to time of descent. When it goes up and stops, my particle reaches the maximum height here. When it comes back, it is coming from here to here. So it goes from here to here in some time. In the same time, it comes from here to here. Again, particle goes from this origin to this point maximum height in some time t. It will take the same time t from here to here. If you see, this is not symmetric. My x motion is not symmetric about this line as it was over here. Right? So this time is same from here to here and here to here is same, but my distance covered is not same because there is a retardation along x-axis. Okay, now let us find out the time of flight. What is time of flight? Time, the particle is in air before it touches the ground again or inclined plane again. Time it's in air. So what is the initial vertical velocity? V naught. What is the vertical? What is the y component of velocity? V naught sine alpha, right? V naught cos alpha is horizontal component. I mean along the incline. V naught sine alpha is perpendicular to the incline. So initial vertical velocity is V naught sine alpha. It stops, that means it is zero. Final velocity is zero. Zero is equal to V naught sine alpha minus G cos beta into time of ascent, TA. So time of ascent is equal to V naught sine alpha by G cos beta, or G cos theta, sorry. It's not beta, it's theta. Theta naught. Now this time of ascent. We know the time of ascent is equal to time of descent. So total time of flight T naught will be double of TA. So T naught is equal to 2 into V naught sine alpha by G cos theta. V naught cos alpha sine alpha naught by G cos theta naught. This is the time of flight. That means it takes time of, if it takes 2 seconds from here to here, it will take same 2 seconds from here to here. But the motion along x-axis is not symmetric about this line. This is where the maximum height occurs. This is h naught and this is r naught. Alright. Now what is h naught? Distance, maximum distance from the incline. That is where the tangent becomes parallel to the incline. That means my vertical component of velocity should become zero. It is there where the particle reaches maximum height. So particle goes, stops, that is reaches maximum height and comes back. So in what time it is reaching maximum height? V naught sine alpha naught by G cos theta naught, half the time of flight. Or I can use V square minus U square is 2as. Final velocity is 0 square minus initial velocity, which is V naught sine alpha naught square, is equal to minus 2 G cos theta naught into h naught. Negative gets cancelled out. So I'll have h naught is equal to V naught square sine square alpha naught by 2G cos theta naught.
Yes, sir.
Right? If you compare this with the constant acceleration motion, it is like this, students. I've got a line. Particles projected velocity V naught along the line under the retardation A. So maximum height, time of flight would be 2 V naught by A. Maximum height would be V naught square by 2A. Over here, V naught is V naught sine alpha naught. Or if I say this is U, 2U by A naught and U square by 2A naught is my maximum height. What is U over here? V naught sine alpha naught. What is A over here? G cos theta naught. So 2U by A, U square by 2A. Alright, you can quickly remember like this. If you just remember this one, that's enough. Even if you don't remember this, it's easy to derive, but you will not have time to derive in exam. So there has to be a way to remember. Logical way to remember. See, this and this are same. In a sense, this is constant acceleration motion, this is also constant acceleration motion along the y-axis. Under constant acceleration A, my time of flight is 2u by a, and maximum height reaches u square by 2a. Here also I'll write the same thing. 2u by a, 2u is u naught sin alpha naught, by a is g cos theta naught. I get time of flight. Maximum height is v naught square, u square by 2a. This is u square by 2 into a is g cos theta naught. Alright, now let's find the range. Two parameters are done. Third parameter range. If we do the range, we are done with three parameters. Then we'll go for, we'll have a discussion about other cases. Alright, I'll erase this. Now, how do I find range? I'll substitute this time equation in the equation of motion of a particle along the x-axis, which is along the plane. This is equal to ut plus half at square. So r is equal to v naught cos alpha naught time of flight t minus half g sin theta naught t square. I substitute t is equal to whatever the time is. R naught is equal to v naught cos alpha naught 2v naught sin alpha naught by g cos theta naught minus half g sin theta naught into 2v naught sin alpha naught by g cos theta naught whole square. After this time, it will reach a distance of r naught, right? After this time, it will reach a distance of r naught. But note one thing, students, at half the time of flight in the oblique projectile on a horizontal ground, it was at a distance of r by 2 at half the time of flight. Because this line of symmetry was exactly bisecting the horizontal plane, horizontal ground. But this is not the case here. At half the time of flight, it is at this distance, which is not equal to r by 2. This is not equal to this one. This is x1, this is x2. x1 not equal to x2. x1 plus x2 is r naught. But x1 not equal to x2. So x1 is not equal to r by 2. It will not cover half the distance. It will cover more distance in half the time of flight, then less distance in remaining half the time. All right. Yeah. If you further simplify this, yeah, what you get is further simplifying and manipulating the terms in the equation, we get further simplify r naught is equal to v naught square by g cos square theta naught into sine of 2 alpha naught plus theta naught minus sine theta naught. This is the formula for range. But it is rarely that you will use formula for range, students. You will not have direct formula questions, but it's good to remember this equation. Hard to remember, but good to remember. Otherwise, you'll find the time of flight and substitute the time of flight in this equation. You'll get range easily. All right. And if you ask you at what time is the particle moving parallel to the plane, it's half the time of flight. At what is the velocity over here? If I ask you, what is the horizontal velocity? Vx is equal to ux plus at. So Vx is equal to ux and the V naught cos alpha naught minus G cos, sorry, G sine theta naught into time of flight t. This is my Vx. So remembering time of flight is easy. Remembering maximum height is easy. I'll substitute the time of flight in the equation of motion for the horizontal, sorry, for the motion along x-axis, which is along the plane. I'll get remaining parameters. Or if you can remember this one, that's great. When only alpha and theta are known, velocity is known, you can find the range. And maximum height is very easy to remember because I can put the analogy with vertical motion with a speed u under retardation a, u square by 2a is my maximum height. 2u by a is my time of flight. U by a is my time of ascent or time of descent. All right. When you apply these things to examples, then you'll understand easily. So that's not a problem. But now let us understand one thing. The particle is going like this. Using calculus as well, I can get H naught and R naught. Okay, that we'll do it when we have some time later, or when you do some problems in after you do the basic math, then we can do that approach. But right now, understand one thing, that particle is projected like this. It becomes parallel to the incline, again comes back and hits the incline. The time at which it becomes parallel to the incline is time of half ascent. From here, again, it hits the plane, again is the same time. And it is not symmetric with respect to this line. My parabola is symmetric with respect to vertical line. But parabola is not symmetric with respect to this line. So this distance will be not equal to this distance. But total distance is r. So understand that it will not cover the same horizontal distance in time of ascent and time of descent. All right, that's one point. Next, its vertical velocity is going to be the same. Horizontal velocity is going to be this one. Vx is equal to this one. But vertical velocity, Vy, is equal to minus V naught sine alpha naught. You can check this by plugging this time in this vertical equation, vertical velocity equation. Vy is equal to uy plus at. Otherwise, you can also think it this way. Think about it this way. I project a particle with u under acceleration a naught. It goes up and comes back with the same speed, but opposite in direction. So in y direction, particle goes up, stops and comes back and returns with the same speed, but in opposite direction. So my vertical velocity perpendicular to the plane is going to be V naught sine alpha naught itself. Speed is going to be same, but in opposite direction, directed opposite, hitting the plane. But this horizontal velocity will not be V naught cos theta, but will be Vx, given by this equation. Vy is going to be the same, V naught sine alpha naught. All right, I hope you understand that. That vertical velocity is going to be the same, but reversed. Speed is going to be the same, but velocity is going to be reversed. But horizontally, if it is V naught cos alpha naught here, it goes on reducing and reduces over Vx, reduces to Vx over here. Okay. But when I say it is reducing, it could become zero as well. Yes, that's a special case. When the horizontal velocity becomes zero when it hits the plane. At that instant, what is happening? My horizontal velocity is 0. I will have only vertical velocity. So if I draw a tangent at that point, my tangent will be vertical. That means tangent will be parallel to y-axis. Because my horizontal component of velocity is 0, my component of tangent along the horizontal should be 0. Horizontal over here in sense, x-axis along the plane. So along the x-axis, my vertical component is, along the x-axis, my velocity component is 0. That means my particle is hitting the plane perpendicularly. All right. So the condition for the particle to hit perpendicularly is my velocity should become, Vx should become 0 after one time of flight. Time of flight tarvata, it should become 0 over here. Only then it means that my particle is hitting the plane perpendicularly. So I will write Vx is equal to 0 at time t equal to t naught. So Vx is equal to ux plus at, which is v naught cos alpha naught minus g sine theta naught into t equal to 0. And this t is time of flight. So what is v naught cos alpha naught is equal to g sine theta naught. What is time of flight? 2u by a. U is u v naught sine alpha naught by g cos theta naught. So v naught gets cancelled out. So I have condition g tan theta cot alpha is equal to g gets cancelled out 2 tan theta. This condition also you don't have to remember, but whenever he says it is going to hit perpendicularly, it means after one time of flight, my horizontal velocity went on decreasing and it became 0. Why did it become 0? Why am I putting 0 over here? 0 over here? Because my horizontal component velocity went on decreasing. It became 0 here because particle is hitting perpendicular to the plane. If it is hitting perpendicular to the plane, its component along the plane should be 0. All right. Okay. All right. Yeah. Next. But now we got a range formula. If I want to find maximum range in the oblique case, maximum range is when theta is equal to 45. I get maximum range. For all other thetas, range is going to be lesser than that corresponding to 45. So r is equal to theta is equal to 45 gives you maximum angle at which the particle should be projected to get maximum range. Over here, for the range to be maximum, I had range as v naught square by g cos square theta naught into sine of 2 alpha naught plus theta naught minus sine theta naught. Everything is constant except alpha here. So sine of this one should be maximum for this to be maximum. If this is maximum, that means this is 1. If this is 1, 2 alpha naught plus theta naught should be equal to pi by 2. If that is the case, my alpha should be equal to pi by 4 minus theta naught by 2. So this is the alpha for which my range is maximum. Given theta naught, if theta naught is 0, it becomes a oblique projectile on horizontal ground. So that becomes pi by 4. Makes sense because alpha is 45 when it is for oblique projectile on the ground, on horizontal ground. But when it is theta is non-zero on an inclined plane, my alpha is for a range away maximum is such that alpha is equal to pi by 4 minus theta naught by 2. All right. So let us say this is 30 degrees, theta is 30 degrees. Then angle for which my range is maximum is pi by 4 minus 30 by 2. So 45 minus 30 by 2 is 15. 45 minus 15 is 30. So alpha should also be equal to 30. It is not 45, note. For maximum range on horizontal ground, it's for oblique projectile, it's 45. But over here it is pi by 4 minus theta by 2. It depends on theta. Substituting this alpha naught back in this equation, I'll get R max is equal to V naught square by G into 1 plus sine theta. This is the maximum range covered on an inclined plane. All right. These formulae, if you remember, that's very good. But if you don't remember, that will come with practice. If you apply it to more and more problems, you'll remember through practice.
Sir, can you write clearly?
Okay. You want to write bigger?
Yes, sir.
I think your camera is not clear, sir.
Blurred? Is it blurred?
Somewhat some clumsy kinds of view. It's looking. That's a-
Is it clear now?
it's-
Okay. All right. So this is about particle trajectory along the inclined plane. And the case we have also seen when it hits perpendicularly. That means horizontally it goes and stops at that instant when it is hitting perpendicularly. What happens to the vertical velocity? Vertical velocity is reversed. Same as V naught cos alpha. Magnitude is same V naught sin alpha, but it is reversed. So V naught sin alpha is a speed at which it will particle will hit the plane, but horizontal velocity is not remaining same. V naught cos alpha naught. It goes on reducing, and if it becomes zero at that instant, the case is when the particle hits perpendicularly. And if a particle hits perpendicularly, it will rebound perpendicularly. All right. And if the collision is elastic, that means if the rebound speed is also same as V naught sin alpha, this particle will retrace its path and come back to its person's hand. If the person is projected from here at an angle alpha such that it is hitting perpendicularly, then it will come back to his own hand. It will retrace the path. If I ask you what should be the alpha naught or what should be the alpha such that it should retrace the path, then in that case you have to project it in such a way so as to hit this perpendicularly. If it hits perpendicularly, it will rebound perpendicularly. If it rebounds perpendicularly, it will retrace the path and ball comes back to its own hand. All right. Okay. Now let's look at a question. Question says a particle is projected in such a way that it hits the plane perpendicularly. All right. I have to find out the time after which it will return to the point of launch. Presuming the collision is elastic. Presuming the collision is elastic, that means if it hits with speed 2 meters per second, it will rebound with speed 2 meters per second. Alright? If it hits perpendicularly, it will rebound perpendicularly. But if it is hitting with 2 meters per second, it's rebounding with 2 meters per second with the same speed, then collision is elastic. That means there is no loss of energy. When the collision is elastic, it will retrace the path and come back to the same point of launch. So what is the total time? Is time of flight taken twice. So all if I do is, if I do twice the time of flight, it's my answer. Right? So what is time of flight? 2v0 sine alpha naught by
Sine theta.
g cos
theta
g
naught.
cos theta naught. But I want total time after which it will come back to this point of launch. That will be 2 into this one. So that is 4v0 sine alpha naught by g cos theta naught. Theta naught is known. I also know the relation in these two. You have seen that theta tan theta naught 2 tan theta naught is equal to
Sir,
cot alpha naught. That's what you have seen. If cot alpha is 2 tan theta, I can write sine alpha.
sir,
Yes.
why did you take four the
See, time of flight is 2. He is asking after what time will it come back to the point of launch. I have projected a particle from here. Because the collision is elastic, it will hit perpendicularly there and it will come back to its own hand. So what is the
Sir,
total time?
no,
Time
sir,
of flight plus time of flight. 2 time of flight.
time of flight is means time of ascent plus time of descent, no, sir.
Right.
It means it goes with the time and come back with the time. It is a type of flight.
Yes, total time of flight. It goes like this, stops and comes back. So this complete time it takes from here to here is time of flight. This total time is time of flight. So that is 2v0 sine alpha naught by g cos theta naught. So double that is my total time, ask time, because he says after what time will it come back to the point of launch? It will come back after time of twice the time of flight. So it will come back to the hand after a time of capital T, which is twice the t naught, twice the time of flight. Is it clear?
Yes, sir.
Okay. Now I'll substitute alpha naught sine alpha from here. I know cot alpha. I have to substitute sine alpha. If cot alpha is 2 tan theta, that means 1, 2 tan theta. This is alpha. Cot alpha is 2 tan alpha, 2 tan theta naught. So sine alpha would be 1 by root of 1 plus 4 square tan square of theta naught. Substitute that over there, you'll get time of flight. In total time for the particle to go, hit, retrace the path, and come back to the one hand. Okay. Okay, now let us see one problem. And as a homework, I'll give you, think about what if it's projected down the plane? How will you get range, time of flight, and everything when it's projected down the plane? I'll do the physical analysis, but you do the mathematical part. You can refer the textbook as well. There are 3 paths shown. Right? You will have to tell me which path is correct. Which path looks correct. There's a particle projected like this. Horizontal velocity is v1, vertical velocity is v2. I mean, along the plane it's v1, perpendicular is v2. When it hits this one, it is v3, v4. All right. Now, can you tell me whether v1 is greater than v3 or v1 is less than v3? It is it is at the time point of launch. That is at the point of hitting the plane, hitting the inclined plane. So is v1 greater than v3 or v3 is v1 is greater than v3? Who is that? Who said that?
Charles.
Yes, Charlie,
Right.
that's absolutely right. V1 is greater than v3 because it's going on retarding. V1 in term to Neet, it goes on retarding like this. It becomes v3 over here, which is less than v1. What happens to v2 and v4? Magnitude is reversed, but can I say v2 is greater than v4 or they are equal or v4 is greater than v2?
They're equal.
Yes, they are equal. V2 is equal to v4. All right, so this is very clear. Now I will draw a trajectory. You tell me whether it's possible or not. I'll draw a trajectory like this with axis of symmetry like this. Is it correct? Time of ascent, time of descent, and the axis of symmetry is like this. This is equal to this. Is it correct? Is a trajectory possible? Is such a trajectory possible? No, it is not possible because my axis of symmetry of the parabola is vertical. This motion is not symmetric with respect to this line. Where maximum height is reached, it is not symmetric. All right, that we know. So this is not possible. This distance cannot be equal to this distance. So in time of ascent, if it travels some distance, during time of descent, it will travel lesser distance because particle is retarding along x-axis. Now I'll draw another line, another curve. You tell me whether that curve is correct or not.
So why V2 is equals to V4?
Yeah, because if I just see observe motion along y-axis, shouldn't if I have a particle along a straight line, I project this with u under retardation A, what happens? It goes, stops and comes back. It will come back with the same speed u, right? It goes, stops and accelerates, again comes back with u at the same time because time of ascent is equal to time of descent. వెళ్ళేటప్పుడు ఆగుతుంది వెళ్ళినాక ఆగుతుంది ఆగిన తర్వాత మళ్ళీ it will turn back and accelerate. When it comes to the same point, it will achieve the same speed because acceleration is same now. This we know from 1D kinematics, right?
Yes, sir.
Same thing is happening here vertically. I mean, perpendicular to plane. If I say that is vertical, perpendicular to plane, what is happening? It is projected under the acceleration of g sine theta naught. So it is going, stopping and coming back. It will come back after, if I substitute Vy, if I take the equation Vy is equal to Uy minus g sine theta naught into time of flight. After one time of flight, if I substitute Uy and everything, I'll get Vy is equal to Uy in magnitude. In direction, it is reversed. So I'll get Vy is equal to minus Uy over here. So I'll get Vy finally minus V naught sine alpha naught. All right, this is from equation. Otherwise, common sense also says along a straight line, when the particle is under constant acceleration, if it is projected with velocity u, it will return to the same point with the speed, same speed u, but reversed in direction. Same thing is happening. It is projected with v2 along this line. It reaches this point with velocity reversed and equal to v2. It is 4 V4 reversed, and magnitude will be same as V2. All right, is that clear?
Yes, sir.
Now tell me whether this kind of motion is possible, this trajectory is possible, such that it's when it is becoming 0, the maximum height is reached. This line, this is lesser than this one. Is it possible? Is this correct if I draw a trajectory like this?
I think no, sir.
Yeah, why is it no? Yeah, answer is right. No, it's right. But why is it no?
Because V1 is need to be retardation.
Sorry?
And it V1 need to be retarded, sir. Then it
Yeah,
need to
V1,
be
yeah, it's retarding, right? So when it's retarding, in this time it will travel more distance. So my correct trajectory, seemingly correct trajectory will be like this. With this maximum height reaching, unsymmetric with respect to x-axis, this is more than this one. So this is correct and this is wrong. All right. Okay, so this is fine. Now let us, it was a case where it was hitting the plane perpendicular to the plane. But now I have a condition that it should hit the plane horizontally. With respect to the ground, it should hit the plane parallel to the ground. So how will that motion be? I have to find the condition such that it will project it like this. It is going and hitting this horizontally like this. This is my horizontal ground. It is going and hitting this plane horizontally. That is parallel to the ground. So what is the condition in that case? I will equate time of flight, two times of flight. So one time of flight is along the plane and time of ascent for the oblique projectile. Look at this. This is time of flight for the inclined plane, which is now this should be equal to, if this is alpha naught, this is theta naught, this should be equal to V naught sine alpha naught plus theta naught by G. Understand this equation. Why did I write this equation? What does it mean? What is this time, students? What is this time? It is the time taken by the particle to reach the maximum height on an oblique projectile on a horizontal ground, right? The time of ascent. 2 V naught sine of the angle. What is the angle with the horizontal plane? Alpha naught plus theta naught. Alpha naught is with the incline. Theta naught is the angle of incline. So angle with the horizontal is alpha naught plus theta naught. So to V naught sine alpha naught plus theta naught is time of ascent for oblique projectile on ground. This time should be equal to this time. Why is it so? Do you understand that? Do you understand that?
No, sir.
Okay. See, this time of flight is anyway this one, which we know. We understood this time of flight. The LHS is understood, right? But RHS,
Yes.
look at this. If I have a projectile like this, an angle of 60 degrees, let's say, or some angle, which is alpha naught plus theta naught. How much time does this particle take from here till the maximum, it reaches maximum height? How much time does it take? How much time does it take from here till it reaches maximum height? Again, same time of ascent. What is time of ascent? V naught sine alpha naught plus theta naught by G. because my vertical acceleration retardation is g, my speed is v naught sine alpha naught plus theta naught. So 2u by a. U by a is my time of ascent. 2u by a is total time of flight. But my incline is such that it is hitting this incline horizontally. You all see this? This is my inclined plane now. This is ground. So this is the time of ascent when I think in terms of object projectile on ground, and this is time of flight for the particle on an inclined plane, projectile along the inclined plane, sorry, on the inclined plane. These two times have to be equal because it is hitting horizontally. When it is hitting the plane, it is being horizontal. When will the particle be horizontal? After this much of time. And that time should be equal to time of flight of the on the inclined plane. So I'm equating these two times. I hope this is clear now. All right. Okay. Now, I got the condition. G gets cancelled out. V naught gets cancelled out. That's the condition for particle to hit the plane horizontally. All right. Okay. So it will not retrace the path if it hits horizontally. It will retrace the path only if it hits perpendicularly like this. If it hits perpendicularly, it will rebound perpendicularly. It will retrace the path. But when it hits horizontally, it will rebound and go further. All right. That part we'll study later. What happens after rebound? All right. Now we have got up the inclined plane done. If a particle is projected down the inclined plane, mathematics part you do it, but I'll just tell you what to do. It's very simple. If it is projected down the inclined plane like this, at an angle of alpha, not with the horizontal, and let's say this is theta naught. This is my vertical y-axis. This is my x-axis. That's how it will come down. My time of flight is again the same. What is time of flight? V naught. I want this component, and this is theta naught for alternate angles. V naught sine alpha naught plus theta naught is my y component of velocity. 2u by a is my time of flight. All right. In this time, I'll substitute this time in s is equal to ut plus half at square along x-axis. I'll get the range. I'll use v square minus u square as 2as. So vertical to get the maximum height. While coming down the inclined plane, it is going to be this way. This will be less than this one. It is not going to be symmetric again. But this time will be symmetric. Time from here to here is same as time from here to here. Temporally it is symmetric, but spatially it is not symmetric with respect to this line. Because my line of symmetry for the parabola is same. See, my parabola ante undi. If I project a particle in under constant acceleration, my cross product is non-zero. My parabola is like this with the axis parallel to g bar. Now I am placing my inclined plane like this or like this, however I want. So my trajectory is same. So my parabola trajectory is same. Absolute trajectory is same. Only thing is my inclined plane now, the range vary ఉంటుంది. So this is going to be the range on an inclined plane, and this is going to be maximum height on an inclined plane. All right, but the trajectory is same. If you ask me to write the equation of trajectory with this as origin, and this as x-axis, and this as y-axis, That is same, a naught x minus b naught x square, x tan theta minus gx square by 2u square cos square theta. All right. Any doubts, students, so far? Okay.
So how did the value is coming from equation?
How's it?
2 will not sign
How we got this
equation.
equation?
Yes, sir.
Yeah, see, 2u by a. If I have a straight line, particle relative velocity u naught under acceleration a naught. What's the time of flight? Tell me the time of flight along this one. 2u by a naught, no? Time of flight ఏముంటుంది ఇక్కడ? It will go and stop after u by a. It will come back after u by a. So 2u by a is the time of flight.
Yes, sir.
Same thing here. Instead of u, you have got v naught sine alpha naught plus theta naught. Why is it this so? This is v naught. My vertical y component of this velocity is v naught sine of this angle. What is this angle? Alpha is with horizontal and this theta. All right. If I were to give you total angle as psi, then my answer would be 2 v naught sine psi by g cos theta naught. That psi over here is alpha naught plus theta naught because I projected it with alpha naught with horizontal and theta naught is the angle of inclination of the inclined plane. So 2u by a. 2 into u by a. What is u here? Component of velocity along y-axis. uy. 2u by ay. What is ay? Component of g along y-axis, which is g cos theta naught. Along x-axis it is g sin theta naught. Y-axis is g cos theta naught. Right? I hope that is clear now.
Yes, sir. Thank you, sir.
Most welcome. Good.
Sir,
Yes.
do we have any chemistry class today?
No. No. We are just going to wind up with this inclined plane projector thing, and then tomorrow we'll do relative velocity of rain umbrella problems and riverboat problems, so that we can start Newton's laws from Tuesday or Wednesday. All right.
Yes, sir.
So I took an extra class so as to gear up. So down the inclined plane, you do the analysis or you refer the textbook, do it, but then refer the textbook. You do it on your own first. You get the range, you get the maximum height and everything, time of flight, and see what is happening. And then you refer the textbook. And I suggest you start doing problems of projectile motion from the book, from the Cengage, that green color, that book, whichever book is suggested now. The Cengage book. This one. You start doing problems from this one. All right. You can start from concept application 1, 2, and so on. Do the examples first, go for concept application, then go for back-end exercises, chapter end exercises. But do it. Any doubts you have got, you can just post it in the WhatsApp or you can ask me in the next class. Posting it in the WhatsApp is better because class will take a lot of time. If you post in the WhatsApp, I'll discuss in the class or I'll reply in the WhatsApp itself. All right. So I hope you don't have any doubts. So solve some problems. Okay, there is one, I would like to discuss one problem based on the concept which we did yesterday. I have a particle, I have a tower A here, one tower here, from where the particle is relative velocity V naught. Another particle is floated from here, let's say V1, and this is V2. V1, V2. Fine. I have to find the condition for them to collide. This is H1, sorry, H2, this is H1, and this is X0. I have to find the condition for them to collide. With this, we'll stop. Because I haven't done any problem on this concept, I'm doing it now. See, for the condition for them to collide is condition for collision is velocity of 1 with respect to 2 should be directed from 1 to 2. That means if 2 sees particle 1, it should see the particle 1 coming directly towards it. All right, 1 ni 2 towards 2 రావడానికి వస్తున్నట్టు చూడాలి particle 2. That means velocity of 1 with respect to 2, the way 2 sees it, should be directed from 1 to 2. It should be directed from 1 to 2. If it is directed from 2 to 1, it goes away. So condition for collision is velocity of 1 with respect to 2 should be directed from 1 to 2. And if there is no acceleration at all, if there is acceleration, things are different. So relative acceleration is 0 ఉన్నప్పుడు, so acceleration of 1 with respect to 2 is 0, as in this case. G undi, so G minus G is 0. So what decides collision is velocity. Once the acceleration is 0, velocity decides the collision, whether they collide or not. So velocity of 1 with respect to 2 should be directed from 1 to 2. Right? Or velocity of 2 with respect to 1 should be directed from 2 to 1. So velocity of 2 with respect to 1 చేద్దాము. Sorry, velocity of 1 with respect to 2 చేద్దాము. So that should be directed from 1 to 2. Velocity of 1 with respect to 2 చేస్తే, this is velocity of 1, v1 minus v2. All right, this becomes plus of minus v2. All right, I add these two vectors. v1 is this way, v2 is this way. So resultant is somewhere here. Let this angle be theta naught. This should be such that it is directed from this to this. So this is theta naught. It should be directed from here to here. Only then they'll collide. But is there a necessary condition for collision satisfied? Let us see. Its trajectory is like this. Its trajectory is like this. Yes, it's satisfied. There is an intersection of trajectory. That's satisfied. So, but the sufficient condition is relative velocity of 1 with respect to 2 should be directed from 1 to 2. Is the relative velocity direction. So, what is tan theta from this vector diagram? v1, v2. Tan theta is v1 by v2, right? Tan theta is v1 by v2 from this diagram. But from this diagram, what is tan theta? h2 minus h1 by x naught. So if v1 by v2 is equal to h2 minus h1 by x naught, they'll definitely collide. All right. Is it understood?
Yes, sir.
Velocity is this way. This is radial velocity vector, vr bar, vr bar. Angle at which this particle is moving with respect to 2 is in this direction, towards 2. It's going towards 2. At what angle? And let's say theta naught is the angle. And what is tan theta naught from here in this vector diagram, velocity diagram? v1 by v2. Now, because it is directed towards 2, it should be same theta as in this triangle. From this triangle, what do I get? This is v2. Sorry, this is v1. This is v2 in magnitude, sides. And this triangle is h2 minus h1. This is x naught. So if I take this triangle, I'll get v1 by v2. If I take this triangle, I'll get h2 minus h1 by x naught. I equate these two, I'll get condition for collision. All right. Okay, let us look at one more case where they can collide. I've got a particle released from here. All right, released from rest from here. Another particle is directed towards it with velocity v naught, or some velocity which I don't know. But all I know is it's directed towards this particle. All right. Now I have to see whether they'll collide or not. All right, whether the condition for collision is satisfied or not. And this angle is, let's say, some angle, so they're directed towards that. But the moment this is launched, that is released from rest. All right, both are launched at the same time. Both are released at the same time. This is velocity, some velocity, and this is with initial velocity 0. So is it necessary condition satisfied? Its trajectory is like this. Its trajectory is like this. Depending on velocity. Velocity is more, trajectory is like this. Velocity is less, trajectory is like this. So yes, there is an intersection of trajectory. If both the particles reach at the point of intersection at the same time, there is a collision. So necessary condition for collision is satisfied. But what is the sufficient condition? Relative velocity of 1 with respect to 2 should be directed from 1 to 2. Now let us see, is that satisfied? Velocity of 1 is in this direction, towards 2, with respect to 2, which is 0. Velocity is 0. So velocity of 1 with respect to 2 is directed from 1 to 2. Because my direction of projection itself is along that particle, directed towards that particle. What is the relative acceleration? G minus G 0. So 2 will appear, 1 will appear to 2 to come straight towards 2. According to straight, it is Rajiv, it's coming straight towards it and hitting it. So R in a hit it. They're always on the same line. This appearing to move towards 2 at every instant. But this goes on this parabola, this goes on the straight line. They'll always be along this line. This line remains parallel to itself, always. And they hit here. So I didn't give you any velocity because irrespective of velocity, it is going to hit the particle. If the velocity is very high, it will hit somewhere here. Right? If velocity is very less, it will hit somewhere here. Well, definitely hit. All right. Absolute motions are parabolic and straight line, but relative motions are straight line from 1 towards 2. That's why you have got collision. Condition for collision is satisfied because velocity of 1 with respect to 2 is directed from 1 to 2. 1 will appear to 2 as if it's coming directly towards it and hitting it. All right, so condition is satisfied. Think about the situation. I'll send a question on this one. A very good question on this one. I'll send a question. You think about this. What is happening here? I didn't give you any velocity. Irrespective of this velocity, provided it is directed towards 2, irrespective of the velocity is going to hit and go and hit 2. All right. If the acceleration is 0, if this g was 0 in deep space, obviously it will go and hit 2 because velocity is towards 2, it will go and hit 2. But even if it is on moon, g by 6, or on earth, or in a lift, it is definitely going to hit it because velocity of 1 with respect to 2 is directed from 1 to 2 and there is no acceleration. When there is no acceleration, velocity remains constant, which is towards 2, it will go and hit 2. All right. All right, students, is it okay? Okay. I hope that's understood.
So can you explain again?
Yeah. See, what is happening here is particle is projected with some velocity, but directed towards 2. And 2 is released from rest at the same instant when this is projected. So both are released. One is released from rest, one is projected from this point at the same instant of time. I'm just studying whether the particle will collide or not. And what is being concluded is they will definitely collide irrespective of what the velocity is. Whether the velocity is high or low, the particle is going to collide, particles are going to collide. Because velocity of 1 with respect to 2 is directed from 1 to 2. And acceleration of 1 with respect to 2 is 0. G minus G is 0. but whereas V naught minus 0 is V naught bar towards 2. So for 1 will appear to 2 as if it's coming straight and hitting it. 1 అలా కనిపిస్తుంది 2 కి, ఇలా స్ట్రైట్ వచ్చి హిట్ అయినట్టు కనిపిస్తుంది, బట్ యాక్చువల్ మోషన్స్ ఆర్ పారాబోలిక్ అండ్ స్ట్రైట్ లైన్. సో ఎప్పుడు ఈ లైన్ మీదనే ఉంటాయి, parallel to itself. If this comes down to certain extent, this will go to certain extent such that this line joining them is always parallel to this one, because its motion with respect to this one, with respect to 2, motion of 1 with respect to 2 is always directed from 1 to 2. So it is always along the straight line. So 2 ki ఎలా కనిపిస్తుంది, ఈ straight line shortening, and then there's a collision here. All right, is that clear now?
Yes, sir.
All right. So let's close here. So if at all you can read something about this from your textbook, that's well and good. I suggest you read about relative velocity and revise your relative velocity concept and come back for tomorrow's class. Tomorrow we're going to do river road problems and rain umbrella problems. I'll do the concept and I'll do some critical problems. All right, so that you can practice problems from the book. I'll do basic problems as well, 1 or 2 basic problems, but I'll go for critical problems where we will do the more of analysis, so that is complete. Right? So tomorrow we'll do river boat and rain umbrella. All right, so that's all for today. Have a great day.
Sir,
Yes.
I didn't get any attendance form.
Oh yes, okay, let me just check.
Sir,
Yes,
how can I listen recorded sessions, sir?
you will once your email ID is added to the link, I mean they'll send a link to you, then you can listen. All right, it will take a day or 2.
Sir,
All right,
you had said that on 8 o'clock we had backlog classes.
yeah, backlog class is 8 o'clock, or we'll do it in the evening. Shall we do it in the evening?
As you wish, sir. We're comfortable in 8 o'clock also.
Okay, how about other students? Shall we do it in the evening? Backlog class? Is evening okay
Yeah.
for you all?
Yes. Yes, sir.
Sir, is it means we don't have any math class in the evening?
No math class in the evening. All right, so we'll have it in the evening.
Sir,
Let me just
timing.
check with the team. Let me just check 1 second. I'll tell the time right away. Or we'll update you in 10 minutes in the WhatsApp. All right. All right, I'll update you in the 10 minutes on WhatsApp. All right. All right, we'll announce in the WhatsApp. Students,
Yes, sir.
all right, give me 10 minutes. I'll announce you in the WhatsApp. All right.
Yes, sir.
But I suggest evening is better because you can at least go through some part of textbook and be ready for the evening. All right.
Yes, sir.
All right, then. Have a great day. See you again later in the
Sir,
next
attendance.
class. All right, attendance form. Okay. Let me check. Let me check. I'll do one thing. I'll take the snapshot of the participants now, so that at least I can update it.